Okay, so I have reverted back to my old faithful. I'm in Inventor and I've got HSM, so I've got my cam tab, and I've drawn 84L. That's the nose cone for the rocket. So I've got a drawing right here, just a 2D drawing. So I'm going to switch back and forth between Fusion and HSM in a couple of videos because I've already loaded the tool package into Canvas, and I already loaded it into my Fusion 360, but I have not loaded it into here. And so what I'll probably do here is just modify the tools as I go. So I've got my drawing or my sketch finished up, so I'm just going to save it, and then I'm going to do a revolve from the axis right here, and that looks pretty good. That looks like a nose cone to me. Looks like it's covering the right dimensions, got all the things that I need, and hit OK. So essentially the only thing, I did not put, I had to go back. I had to get back in there and edit that thing because I did not put a radius down here on the end. So I need to go back here and fill it in. 25 thousandths, I believe. Here and here. Yep. Close that. Go back. Finish that sketch. There we go. Now I got my radius on there. Oh shoot, I missed a chamfer up here too. My gosh, I'm as bad as a student. Go back in and edit that thing. I'm trying to knock out several videos today, so it's kind of going back and forth on some stuff. So I'm going between quality and this class. So let's put a chamfer in, and it is a 10 thousandths. Oh, barely worth even putting in there. You connect to that. Looks like I got something going on here. Let me pan around. I don't know that it matters terribly on this part, but here's my 475. That should be the 950 for the OD, but if you look, I'm going to draw a line right across here. I actually go up above there in this section here. I'm going to trim that out. Bring that back in. And like I said, I don't think that makes much difference on the part that we're working on. Really, these are kind of just play toys anyways. Put 10,000 chamfer in that. I think I have everything that I need now. If not, we'll just say we do. Finish that sketch, bring it back to Revolution, and there it is. Now, I went ahead and put chamfers on the fronts and the backs of my threaded parts. We'll go ahead and thread that. Change that 3/816. And it is a 3/816. It's on sheet 2 of 2, 3/816. There's not very many threads on that part. It is right-handed and it's external, so it's A, and the size of it is 2. Call it good there. So if you are doing threads on Inventor, I've always used an add-in called Cool Orange. You can download it and it'll populate up here in your tabs. On this version, we just updated to 2019, and when they did that, they did not bring in all of my add-ins with it. So right now I don't have it. So that doesn't mean that it's not putting the threads on there. It just means that it does not create real threads as you're viewing them. So what you're really getting is just kind of a overlay of a picture of threads, which is okay. I mean, it's not killing us. There's nothing wrong with it. still going to thread and do what we want. And even if it didn't, we can go in and make some modifications to what it is that we wanted to do. So here we have our part, and pretty happy with most of the things on it. And it actually looks like, as I'm looking at my sheet 1, there is a dimension of 1.375. I'm going to go back and take a look at that and just see where we ended up on that when we made our modification to our radius there. So from this point to the end point, a little bit off. Alright, so let's do this. Let's go ahead and make it 1.375. Push that back. And then finish the sketch. Alright, that looks a lot better. Looks more print. That's the great thing about HSM and Fusion as well, is that all of these things are global. Everything's moving along with it, so I don't have, even if I had changed my program, or I changed my part after I made my program, all these things are going to follow along with it. So I've got my drawing, and now I can go in and start applying some machining. So I go to the Cam tab, and I'm going to start doing some turning. So I can come in here and go profile, get a little more room there, and pick the tool that I want. I don't have, and I tried to import that HSM package, and it did not quite come in the way I wanted it to. So what I'm going to do is, I've got kind of a generic set of tools here. So I'm going to just create and modify just kind of as I go. So I got a VBMT, which is similar in size and shape, so I can edit it. Carbide, we can call it tool number 1 if we want to today. And non-reversible, ours is actually reversible on our insert. That's a 35 degree. Let's see if it has a 55 degree option in there. There's one. Let's just try to make it as close to being what we really have. Okay. I'm pretty sure the ones that we have are the same ones that are Kennametal, and they are not reversible. So two-sided, not reversible. And let's see, corner radius is a lot sharper than that, I'd say. I don't have the inserts in front of me, but I would say probably something a little closer to that. Yeah, everything else seems like it'd be okay for right now. Something doesn't look right. Okay. This thing flipped over and around. And we need to look at what our stock size is. So this part, I think it comes from a 2-inch stock. So got our model. Oh, you know what I did? I need to get rid of this first. Come back out of there, go back into my setup. Yeah, I started a setup, or I started an operation, but I never actually did my setup one for it. I knew something wasn't right, but I just couldn't tell exactly what it was going on there. So here's my part. Get this thing looking just a little bit more like it ought to. And we're doing a mill turn, so you got mill, cutting, mill turn, and alright. Let's go to stock. Our diameter is 1 inch, That can be 2 inches. Go from the front, and let's give it an offset of about 50 thousandths. Post-process, we're not concerned about what offsets or anything that we're working with right now. Okay, everything else popped in okay. I often start my drawings wrong and don't actually get what I want where I want it. And this one didn't turn out too terribly bad. So there's my stock, my round stock, my 1-inch aluminum stock, and I think I can, let's see, no Z-axis, rotary axis selected. Okay, so let's go to Z-axis. So my Z-axis, no, I want to flip that. Yeah. Okay. So this profile I never did anything with, but I need to do something with it. So it's still there. And turning on cam has been something that we've been doing for a long time. I've kind of got this thing flipped around, but it'll be okay. There we go. I feel a little more comfortable about that. Okay. And so I've got some stuff that we talked about last time, how I want to control my tool in computer and control where, inverse where. Fusion is not going to give you those options in there. So what do I want to do? Kind of do some lead in action if I want to have a lead in, lead out on there. Most of those things, but at least for now, we can kind of start with stock. All right. So this particular, so a long time ago, this really would have bothered me about the way that it faces it off or does not face it off. I can go in there and actually force some facing off. So I've got up here, I've got turning face, I've got profile and grooving, turning, I've got a couple of turning and parting options, I've got secondary spindle stuff, I've got a couple different things going on. I can do this as a face-off pass, or I can just go straight into the actual lineal turning for it. So if I simulate that, so my red is a little bit of collision detection that's coming up with. I think for what I've got, it's not going to give me much problem. I do want to come back in and do this though. I do not want to take a finish pass across there. I'm going to go ahead and simulate again after that. Now, by doing that, since my 55 degree didn't have enough clearance to get into some areas like down into this section here to do the chamfer, this 55 degree, you could tell it knew at least that it was not going to be able to do that. So what I'll do now is I can just do another operation, and I can do another turning operation, I can do another profile operation, I could come in and face it, I can do really essentially whatever I want to do there. And so I can do a profile, or if I want to, I can duplicate what I've got. And kind of just depends on what you want to do. So I'm gonna call this my rough passes, and I'm gonna call this one my finish passes. Finish pass. Now, I'm not going to use the same tool. I'm just using this as an opportunity to see what you can do with duplicating. So let's call up a new tool, or let's take this tool and duplicate it and open it up, and we're going to call it tool 2 using offset 2. It's carbide. We can still call it a VBMT. Doesn't make any difference to me, but we are going to change the angle on it, 35 degrees. So now that's tool 2. Okay. So now it hasn't figured out, or we haven't told it any different, so it thinks it's trying to rough it. So now we need to go into our options. We do not want to rough it. Single pass to finish it. Barely has enough clearance, it looks like, to get inside of there. Now it shows collision in the red, but I think that we're going to be okay on that. We could come in there and see a little bit of, or tweak just a little bit of what's going on with that to get some of those things out of it. I think from what we've got here, just knowing what I know about this tool and about what's going on with it, I think that we're going to be okay there. So that stuff's done. Tool 1 is almost always our rougher. Tool 2 is almost always our finisher. This is probably one of our easier ones to do, because as we get into some of the other ones, we're going to get into some pretty wonky little things. So I'm going to have to flip back and forth as we're working on this one, just to come in and try to remember what all we have for our grooving options, and then we have a normal parting tool here. So it looks like this groove right here is 65 thousandths, and so I can go back to my model and edit that sketch. Just jump in there and see. Take a quick dimension on it from here to here. 65 thousandths. Yep. Finish that sketch. Go back to my cam. Regenerate those if I want to. Now I have a couple of tools that I have gotten from Kennametal, and one of them is a really narrow tool, and it is, and I'm going to pop up my Fusion that I have here, and I think I already have some stuff set up, if I can find it. Go to manufacture, and in my tool library, in my local, and this cam lathe tool is already set up and ready to go to download in your first turning module in EDT 134. So let's see, here is a groove square, and let's see, that insert width is 118. That one will not do it. This is 79 thousandths, and this one is 63 thousandths. Alright, let's see. Is that going to be what I want it to be? Some of these dimensions that they gave us off of the CAM package, and I downloaded this from Titan, and then just did some modifying, because we're not using the carbide drill, and we're not using a carbide drill either there. So we'll just be using high-speed steel 5/16 and 421 drill there. So I believe that our tool that we're using is going to be right at about 65 thousandths wide, and I think we got enough tolerance on this part. We can probably come in there with one plunge cut for the 65 thousandths. The downside of that is it does not leave us hardly any room to play with on our threading. So we'll shut that thing down, come in here, and we'll do, let's see, we can do a single groove, and let's come in here and see what we've got. Turning samples, turning OD groove. I don't have anything that's even remotely close. So I will select this guy, and I'm going to go back into it and modify it. Square groove, it is, oh my gosh, it's going to be tool 3, and our insert in inches is going to be 63 thousandths. Let's just say 63 thousandths all the way through. And it is square. I think we got a little bit of corner radius, but not much. Let's actually just say we got 5 thousandths in there. So on this one, constant cutter or constant surface speed is used. That'll be G96. It's going to allow your spindle to speed up as it goes down to a smaller diameter. It's going to slow down as it goes to a bigger diameter. And this one, if I wanted to keep a consistent RPM for that, I can come in here and make it a constant RPM. So we can try that at this one and just see what it looks like. Normally, I would use this and use that surface footage on there. We can try it either way or try both ways and see what we think about it. So I'll let you guys play around with that one. Okay, and we'll select it. And so our groove. Let's see. Come down, let's see what that does. No. See, that cuts into it. So we need to come back into it. Front. Still going into it. What do we got going on here? There we go. All right. Single groove application there. I think what we're working on, especially this being our first one, we'll spend more time talking about constant surface footage and cutter speed as we go. This would be a good one, just kind of get a feel for it. Now, that way this thing's not spinning so fast as everything's happening. We are going to get a lot better surface finish if we will go ahead and use the G96 on this. All right, so now we need to do some threading. I already have a decent little threading tool set up there. What I don't like about this is it's only going to this edge, so we're going to need to be able to move on just a little bit past that particular thread. That's what I don't love about having the chamfer on that back side. We'll leave full retraction on. Let's take a look and see what we think here first. What I'd like to do in this one, the goal is to not do any modifications to it once it goes into our part, or once we output the program. We're hoping to get a finished program all the way through. So what we have to be really careful with, let's go 50,000 in front of that too. It's 50,000 from the beginning of the thread, so let's go 150. Start out just a little bit in front of it. Okay. So I think this is a little bit better looking thread, like this, but still it's really close, and if we watch the simulation, we're going to have to go down further because we're actually not getting, if you watch the thread come across, it's not actually getting through. Close that. What I don't want to do, this front edge is not the center point of the tool, it's the front edge of the tool. And it doesn't necessarily know that on the tool itself, since we didn't use an imported library or geometry, and we kind of just used what we had and just did a quick modification to it. So we want to watch, what we essentially have here is 63 thousandths plus whatever size that our chamfer was, which is like another 40 or 35 thousandths. And so we've got about 100 thousandths there, so we could go all the way and go even 90 thousandths. That's still going to be 10 thousandths off the front face of that, and that's going to be some help for our thread, but as far as simulation goes, it's going to look even worse. Yeah, see how you see it? You see it turn to red to there. Okay, so I have, up until this point, turned the entire thing, and let's see. Alright. We've got a part. Now, we've got, it looks like a big dust collector or something, or a vase with weird threads on top. So we've got to get something that is separated from there, and so what we're going to use is a parting operation. That'll be our last tool that we use. That's a tool that we already have. It's not one that we're importing in. So there's face off there. Let's see, parting is here, and parting could also happen from sitting over on this left-hand command, right-click. And let's find a turning, and we have a OD groove already there. Let's edit it. That's not what I want. That's a round groove. I should have known that because it's a round groove. Alright, so I've got a tool here, and it is a 118 thousandths. And I've got essentially no tool nose radius there. just a pretty straightforward grooving tool. Okay, so that's my tool part off. Now I can do a couple things here. I can peck it. If I do that, it's going to have to peck like 50 thousandths, 10 thousandths retract. I can either reduce feed rate, reduce parting feed rate, and it's got to be at, yeah, about 400 would work, maybe even 450. And reduce that feed rate, allow a rapid retract, no stock to leave, and hit OK. Alright, now it looks like it went through the part, but what we really are over here. Okay, parted it off there. Almost looks, I mean, it's taking it all the way down. And that's just the end of our part in there, I think. Close it. So here's kind of where our dilemma starts to come into. I'm going to regenerate these real quick. I've got 1, 2, 3, 4, 5 tools set up. I've really only got 4 stations on my setup. So what I'm going to do is I'm going to make a quick change in this roughing operation here. I'm going to rough and finish with the same tool. And let's see, I want to use this same tool for this. Select it and hit OK. So now I have 2, 3, 4, and 5, and so now I can come in. I could just renumber all those tools, or I could leave them where they are. It doesn't really make a difference. I mean, for some machines, for ours, it will make a difference. And so what I want to do is I'm going to come in and just change some of my tool stuff around, and I'm going to change that into tool 1. So 1 and 1 now. Change to 2. To 3. And 4. Probably an easier way to do that. Well, that's 6. Okay. Simulate it back again. So now I'm up here. I can go ahead and post my program, or see, I've simulated already. So come in, take care of any last things. One thing I want to do before I keep going is I need to go ahead and rename this and save it, because what I have a habit of doing is not saving some of them, and since I've gotten used to using Fusion, it's no big deal because everything kind of follows along with it, and since it's it's all cloud, I don't have to really worry about it because I can open it up anywhere. That is not the case with this one. So where I save it really starts to matter. So if I can regenerate this or generate this. Alright, so pretty happy with that now. So I just do file and then I do a save as. For this one I'll just go ahead and save it on the desktop. Okay, and then back step 1, post process. Okay. Now we need to go to Haas turning and name this whatever you want. 8400 is what I'm going to call it today. Okay. So the only things that I'm unhappy about this, I've got a G96. I'm not super happy. I've got a G50 of 5000, which is super fast. That's my max spindle speed. So just looking at the way that this starts out, tool change is cool. I don't want chip conveyor and all that stuff turning on, so some of these things I need to come in and edit in the post. G54, turn coolant on, wrap it over to here, max spindle speed, turn the spindle on. Normally if I was handwriting that program, I would turn the spindle on before I even moved. And so I got line numbers everywhere, and I don't really want to have some of those things. So I'm going to make some quick changes in this. So go back to here and go to post processor and open configuration. So sequence number is false. When they do, they're going to be by 100s, or yeah, starting with 100 and go by 100. Let's see. Optional stop on. So there's my max spindle speed. And so that's 100 times 60, and I need to lower that down. And actually, probably a better place to do that. Let's do this. Let's go ahead and save it. And we'll go back and look at something else. And so let's see what changed in there. We were 8400. So I took out all my tool numbers, missed that one. Let's do this. We'll go back to post process, we'll open up the configuration. And we'll do sequence number on tool starts. Sequence number is false, sequence number starts. Let's go back up to the top. I want to do a find. Not seeing on this one. Optional stops, sequence increments, sequence number starts. And it's possible that It needs a sequence number, especially if it's going to run any type of G71 or any of those operations. So let's go ahead and let it output at true, and we'll just have to know that we're not in love with that, or at least I'm not in love with it. Okay, so I'm going to close that and come back, fix a couple of things that I have here. In my setup, I did not say the program number should have 8400, and that's just because it's 84L. And then close that, and in my rough passes in my tool, I should go in and edit it. And let's go speeds and feeds, see if I have a way to just max my spindle speed here. I was thinking that we did. Maybe not. Okay. Let's go into the setup and see if we've got an option to do it there. No. Nothing there. Okay. So we go back. Open configuration. Let's see what this looks like. So that's line 50. Now we're maxing our spindle speed at 2000. I feel a lot better about that. Let's see. Probably less happy with my tool number, or my numbering, because it's insanely high. So I would, for just me personally, I would go in and play a lot with the configuration. I'll play for just a couple minutes with that. Let's start at 10 and go by increments of 5. Probably what it was originally. Let's see if we've got chip transport maybe. So we need to go in and change some of that chip transport information. Probably can just put it in parentheses and shut it off. And so what I do whenever I'm in here changing things, I just look at the line that I changed, and that's 418. Close that, save it, close it, post it. Let's see, M31. It didn't shut off any of those things. Now, I won't keep messing around with that stuff right now, but we will want to do some changes on that stuff later on. Taking out, when I have you guys mess around with the post a little bit more, have you work on that and work on that. The rest of the stuff I feel pretty good about. I like the fact that now, different from the mill has this tendency to turn coolant off up here and then turn it on down here, and that's something that can be changed as we go too. One thing I wanted to look at is the threads. So in this one, what I don't like about the threads is that it isn't really outputting a cycle for threads. It'll work like this. It's just not really what I would want to do. So pitch is probably right. Let's see. 1 divided by 16. Actually, pitch looks a little bit off. So it was 3/8 16. Oh, that's for feed rate. Okay. Parting comes out pretty long. That would have been better done by a cycle. So I don't know. This is where I'm probably less in love with this particular. I think I like milling on this just a little bit better. So I want to be able to come in and use a cycle on threading if I can. And then, okay, there's cycle, use cycle. And so let's just generate that again. And let's just see if that'll give us an option in this guy too. Let's see it. We can come in and do a G75 and just peck it at the same time, and then that would save us some lines. It would also just make a better part. So post-process, some of this stuff we're just going to have to live with for today. So here's a G92. A G92 is a single pass for threading, which is okay. It's not what I would probably choose, but it does give you the ability to do some different things with threading. And so it's not a terrible one to use. It's just probably just not the one that I would generally pick. So it'll be okay for the thing that we're using. What I'm having a little bit of problem looking at is that we have a 3/8 16 thread, I believe. Yeah, 3/8 16, but our pitch is wrong. So our pitch is sitting at 78.7. So I'll go back in here. I want to look at our thread. We're 3/8 16 2A. Okay, so that's not right. And so I calculate my pitch by 1 divided by 16. It should be 1/16 of an inch. So I'm going to go in and just manually change that. Unless I'm not seeing something right, that may very well be possible. That is what I think that our pitch should be. No spring pass, that's just a finish pass across there. Now I will do a final generate and then simulate it. Oh, sorry, didn't mean to simulate it, and do a post process on it. For feed rate now. That looks right. Okay, so that at least gets us started in some of our stuff for Inventor. Fusion, you can watch the Titan video to get you straight and set up on that. I've already inputted or downloaded the CAM package, or the tooling package for Fusion, so it's already there in Canvas. And so if you look right there in Canvas, you can see CAM lathe tools, and you can go ahead and import that one. And that one's pretty straightforward to download. And if I hadn't showed you that before, you can go into your manager, go to local. At local, you can import tool library and then take it from wherever you have downloaded it from. This was originally the Rocket one. I modified it, made it the CAM lathe tools. Load that in, be able to work from there. So, okay, that's it. See ya.